So let's complete Lesson Master 8.5, and looks like these are geometric series. And so let's go ahead and put that formula at the top so that we remember what formula we're using. And I want to stress again that this is n and this is n. There's one of the most common mistakes is that people want to put n here and n minus 1 here, because that's what our formula looks like when we're looking at just a generic formula for a geometric sequence. But for the series, these n's should always match. See how here this says n and this is n minus 1? That's because it's the formula for the sequence. So we're supposed to, for number 1, find the sum of the first 6 terms defined by this. Now I do want to note that in this sequence here, it can almost be confusing, and we could think, oh, 1/3 is the first term, but 1/3 is the thing being raised to the exponent. Therefore, it's the ratio, which means the first term is right here, which must be 1. It can't be 0, because if it was 0, it would just knock all this out. 0 times anything is 0, and we'd be done. So it must be a 1. So I'm going to rewrite this from n equals 1 to 6 of 1 times 1/3 to the n minus 1. I think that might help us a little bit. And then we're going to be doing our summation, or our geometric series. So s of 6 is the first term, which is 1. 1 minus 1/3 to the 6th power, because remember, we want to have these two match. All over 1, and the denominator for this sequence is going to be 1 minus 1/3. Now, if rather than writing 1 minus 1/3, you just want to erase that and put that as 2/3, you can go ahead and do that. And we're going to bring out our calculator. 1, and then in parentheses, 1 minus, don't forget to put that 1/3 in parentheses to the 6th power. And then when I divide by 2/3, I have to remember to put my 2/3 in parentheses. Otherwise, my calculator will first divide by 2 and then divide by 3. And we want to divide by the fraction 2/3. And I get 1.49794238.7. Does it say what to round to? It doesn't. I'm just going to leave it like that. For my next problem, it says what's the sum of the first 5 terms of this sequence, where the first term is 70, and we're multiplying by, that is a -4 by the previous term. So that means that I would be looking at, first term is 70, my constant ratio is -4 to the n minus 1. And I'm looking at the first 5 terms, so I'm going from n equals 1 to 5. So for my geometric series, that would be s sub 5 equals, the first term is 70, 1 minus, make sure you protect that -4 with parentheses, because you want to make sure that that negative sign is raised to the power as well, all divided by 1 minus -4, which is, of course, in the denominator going to become 1 plus 4, or the number 5. So I'm going to go to my calculator, and I have 70, it's the first term, 1 minus, don't forget to protect that -4 with parentheses, to the 5th power. And then I'm going to be dividing by, I know that this is 5. If you did not recognize that and you want to type in 1 minus -4, you can do that. And we get 14,350. Okay. Let's go to number 3. We're given the formula for the sequence. So we have a first term, we have a constant ratio, it's to the n minus 1, therefore this is the first term. And we're going to do a summation of the first 11 terms. So s of 11 is the first term, 4. 1 minus, don't forget to protect that negative 3/5 with parentheses, to the 11th power, all divided by 1 minus negative 3/5. So I'm going to use my calculator, 4, and then parentheses, 1 minus negative 3/5 raised to the 11th power. And then I'm going to divide by 1 minus, in parentheses, negative 3/5. And I'm going to let you guys put that in your calculator and get that answer. Make sure you protect the negative 3/5 with parentheses as well as the entire sum. Let's go on to our next one, the geometric series, and they give us these terms. So we've got to figure out, first of all, what the formula is and how many terms there are even in between here. So we know that our first term is 18. To figure out our constant ratio, we can simply take, remember, ratio is term divided by previous term. So I'm going to take 6 divided by 18, which is 1/3. So my constant ratio is going to be 1/3. And my first term is 18 to the n minus 1. What I need to figure out is which term is 2 divided by 81. So I'm going to keep going here with 2 times 1/3, and I get 2/3. I'm going to multiply that by 1/3, and I get 2/9. If I multiply that by 1/3, I get 2/27. And then I would get to 2/81 would be my next term. So this is the first term, second term, third term, fourth, fifth, sixth, seventh term. So I'm adding up the first 7 terms. So my summation is the first 7 terms, where my first term is 18. 1 minus 1/3 is my constant ratio to the 7th power, all divided by 1 minus 1/3. Use my calculator. 18, in parentheses, 1 minus, don't forget to protect that 1/3 with parentheses, to the 7th power. And then I'm going to divide by, I know that 1 minus 1/3 is 2/3, so I'm going to divide by 2/3. And I'll get my answer. I'll let you guys put that in your calculator and do that part yourself. And let's go on to number 5. We're given x to the 5th to the n minus 1, and we're adding up the first 10 terms. X to the 5th must be my ratio because it's what's being raised to the power, which means again that my first term is 1. So I'm going to rewrite that from n equals 1 to 10 of 1 times x to the 5th to the n minus 1 power. So when I go to do my summation, I'm going to actually do number 5 over here. It would be the sum of the first 10 terms. The first term is 1. 1 minus, my ratio is x to the 5th to the 10th power. So remember, these should always match. All over 1 minus x to the 5th. So in the numerator, I get 1 times 1 minus power to a power. We multiply, so that becomes x to the 50th, all divided by 1 minus x to the 5th. We know that 1 times anything is just what we started with, so we just get 1 minus x to the 50th divided by 1 minus x to the 5th. And that's as far as I can go since I don't know what x is. Let's go into number 6. The sum of the first 15 terms of the geometric sequence with the first term of -4, constant ratio of 1/2. And we want the first 15 terms, so n equals 1 to 15. So I'm going to do the sum of the first 15 terms. The first term is -4, 1 minus 1/2 to the 15th, all divided by 1 minus 1/2. So using my calculator, start with my first term, which is -4. In parentheses, 1 minus, I'm just going to go ahead and use 0.5 for 1/2 to the 15th power. And then I'm going to divide that by, I know that 1 minus 1/2 is 1/2. I'm going to divide that by 0.5, put that in my calculator, and you'll get your answer. All right, let's look at number 8. On her birthday every year, starting at the age of 22 until retirement at the age of 67, Beth plans to deposit $1,800 into an individual retirement account, IRA. Suppose the IRA will earn 3.8% annual interest. So we've got to think a little bit about this $1,800. Is that the zero term, the starting amount, or is it the first term? It says that starting at age 22, she's going to deposit $1,800. So it's not saying after a year she has $1,800. That's her starting amount at age 22. So $1,800 is going to be the starting amount, and it earns 3.8% interest, so that's 1 plus 0.038. And because this is the first term, this is going to be to the n minus 1 power. We do need to figure out how many years have passed here, from 22 to 67. So when I subtract 67 minus 22, I get that there's 45 years. So it'd be from n equals 1 to 45. And actually right here, I did say to the n minus 1. This should just be to the nth power, because we said that the 1,800 was not the first term, it was the starting amount. You guys are probably like, wait a second, Miss Liz, you just said it was the starting amount. Yes, this is the starting amount. I'm going to label that so I don't forget that again. That's the starting amount, which means this is to the nth power, not to the n minus 1. If we want to write it using n minus 1, we're going to have to find that first term. And so I can use this as the answer to my first question, actually, using sigma notation, write the series representing the amount Beth will have in the account when she retires. I can use this right here, but then in part B, when it asks me to evaluate the series, which means I need to do my summation, when I do my summation, I'm going to need the first term. Because this is the zero term, I can't use this in my summation. I need to use the first term. So I need to find the first term. I need to figure out, after that amount has been invested, how much is she going to have? So I'm going to use my calculator, 1,800 times 1.038 to the first power after a year. She's going to have $1,868.40. So that's going to be the amount at the end of the first year. So S sub 45 is 1,868.4 times 1 minus, the ratio is 1.038 to the 45th power, all divided by 1 minus 1.038. And that's what I'll need to put into my calculator in order to get the total summation. But we'll do that in our next video.